right, thank you very much. I did not know that boop was the technical term for what you do with those badges, so I learned something new. So I am Shaun Gordon. I am the New Relic's Director of Information Security and Compliance, and today I want to talk to you about application security. And I want to start off by making two assumptions about most of you in this room. So the first assumption is that most of you probably want to develop and deploy applications quickly. Otherwise, you probably wouldn't be here. The other assumption, though, is that all things being equal, you'd probably also like those applications that you're developing to be secure. And a lot of you might have heard in the past, and a lot of security professionals might have told you before, that those two things are in conflict, that you can't have speed and security. You have to sacrifice one for the other. Well, I happen to believe that's not true. I think you actually can have both speed and security. But what it means is we have to change the way we've traditionally done security. We have to modify the way we've done things in the past to fit into this new world. And so that's really what I want to talk to you about today, is how we're doing that in New Relic. So let's start by talking about what I mean by speed. So when I started in the security industry about 12, 13 years ago, I was working for a company that was primarily a box software company. And we released new software about once a year using very traditional waterfall methodology. If you've got year cycles, you got a lot of time to do security and get things right there. And then along came the web, and things got a little bit shorter. We started doing releases once a quarter, but still using this very traditional waterfall methodology. And I remember back in these days, we'd like one Saturday every quarter, we'd all get in a room, get there 7 a.m. in the morning, and basically work through at midnight to do that one quarter's release. But things changed. We started talking about Agile, and we moved to 6-week, 4-week, even 2-week sprints. And we had to start to figure out how can we do security. And we're still kind of figuring that out. But things continue to accelerate. So when I started at New Relic, I started about a year and a half ago. And we were about 140 people in the company at that time. And we were releasing twice a week. Today, year and a half later, companies, 300 plus people, we're now releasing daily. And there are many people, including, I'm sure, people in this room today, that are releasing even more frequently than that. They're doing hourly releases, maybe even more frequent than that. And the problem that we face in the security industry is that most of the security professionals are still stuck somewhere here between this traditional 3-month waterfall methodology and the Agile. So we've gotten really good, as I mentioned, of getting security and figuring out how to do security in waterfall. We're starting to figure out how to do it in Agile. But New Relic, and probably a lot of you, are here. So how do we do security? How do we make it work in this environment? And that's really what I want to share with you today, is we've started to adapt things at New Relic, and I'm hoping that some of the stuff we're doing are things that you can all adapt, and you can learn something about how we've done this. So just a real quick refresh. Actually, Lou touched on this morning, so he did some of my work for me. But for those of you who've only ever worked sort of in a DevOps Agile environment, this is a traditional waterfall methodology. So basically, you have a set of people who are going to define what are your product requirements. And then once they've defined those, they hand them off to a separate set of architects who are actually going to change those requirements into a design. Once the architects are done, they hand it to the developers who are actually going to build the thing. They then hand it off to QA, another separate set of people who do your testing. Once they're done with that, they hand it off to yet another set of people, the release engineers, who release this thing to production. And once you're in production, you need to maintain and patch this thing, so your job isn't over there. So that's your very traditional waterfall SDLC. And as I mentioned, we've gotten good at doing security in this model. And it really tends to be about 3 things for us. It's about checkpoints, controls, and formal processes. So let's look a little bit at how we overlay this security, this model, on top of that SDLC. So this is a traditional security SDLC, the sort of thing that I used to work with all the time. We start off in the requirements phase, just as we have regular requirements. We define security requirements, functional and non-functional security requirements. Once we get to the design phase, your architects have designed this thing. We have the security folk come in and do a review of your architecture. Have you missed anything? Is there anything more we should be doing here? And one of the tools we like to use in the security industry is threat modeling, and I'm going to talk a little bit about that soon. But basically, it's a mechanism for identifying what are the real threats and then addressing those threats. Once you move to development, you want to make sure your developers are actually developing this securely, so they're not introducing new vulnerabilities like cross-site scripting or SQL injection. So you make sure they're trained. And one of the tools we use to help here is what we call static analysis. And the idea behind static analysis is you actually take your source code, you feed it into this tool, and it produces a long list of results of potential security vulnerabilities. And these can be very long results. But it's basically looking at your source code. And then along the way, we want to continue to test for security vulnerabilities and make sure we're actually building what we're supposed to build. Once we move over to the QA phase, we generally use a tool we call dynamic analysis. So this is something where basically we are spidering the website or your application, visiting as if a real user would visit, and once again, looking for vulnerabilities that you might have and then reporting on those. And then finally, as part of QA, of course, you want to make sure you're actually building your security requirements that you defined up front. Prior to release, we always like to do some sort of penetration testing. So some of you have probably been through this sort of thing before, but basically this is where we get a white hat hacker to come in and actually try and hack the site and look for vulnerabilities. So a very manual process, followed usually by the security team coming back and looking at everything we've done over this whole cycle and seeing, are there additional things we've missed, are there things we should have done? And this usually includes things like actually inspecting the code manually. And if everything looks good, security signs off, we move to production. Once we're in production, we want to make sure we continue to scan for vulnerabilities because we're going to be patching and changing things along the way. And that penetration test, we probably want to do that pretty regularly too. Usually we're going to do that about once a year. And so then layered on top of this, we actually make some of these things, and this is once again the traditional model, checkpoints, gates. You cannot move from one step to another until security has actually gone in there and said, yes, you're good to go, and check the box. So you have to define your requirements. Until security sees the requirements they want to see there, they're not going to let you go into design. Until you've had your security architecture review, security team's not going to let you actually start developing. So these become very formal checkpoints. And then on top of that, there's a few other things we tend to like to see in this traditional model. The first one is a separation of duties. So the idea here is that you have developers who are developing, and you have release engineers who are releasing, and developers should never be the ones actually releasing to the live production site. Another thing you'll see very often is a formal management sign-off for every change that goes live. So the idea here is that somebody in management, sometimes senior management, has to actually review every single change going live and say, yes, I understand this change. So they might not be looking actually at the code, but they have to understand what it's doing and say, yes, we're cool, we can go live. And then finally, limits on production access, generally locking down production so developers, QA, nobody has access except your sysadmins. So that's our traditional security model. It just will not work in a continuous deployment DevOps world. It's too heavyweight. There's too many checkpoints. You can't have somebody checking a box if you're releasing 20 times a day. So we need to modify this. So let's talk about, what would we need to do if we were to modify this to work in this environment? So let's start actually, and I sort of call this whole thing, continuous deployment security. And so let's start with, what are the requirements that we would need to make this work? First of all, whatever we do, it's got to have little to no friction. It just cannot slow us down. We want to move quickly. We don't want security being the one that's slowing everybody else down. It's got to be very transparent. We want no significant changes to what developers do. And this is actually a real key point for me. This is almost a mantra for me. I believe that developers should not have to change the way they do their job for security. I think the burden should be on the security professionals to change the way we do security to fit in with the way the developers are doing their job. And then finally, this last point, it might seem sort of obvious, but it's actually got to make us more secure. I don't want security for security's sake. I don't want process for process' sake. I'm not going to put something in my process just because everybody else in the industry is doing it and they say you should do it. I want to make sure it's actually measurably making us more secure. So how are we going to deliver on these requirements? Well, we're moving fast, so we're going to have to rely on automation. As much automation as we can do is going to be important. Developers, we're not going to get security's eyes on everything, so we want to make sure the developers have the right training to understand security, and they're empowered to be responsible for their own security. If we do have to have processes, and you will see we have a few processes that I'm going to talk about, but if we have to have them, let's make them lightweight and very easy to follow. And we're going to rely heavily on triage. We can't get security eyes on everything when we're releasing 20 times a day. So we're going to have to pick and choose what do we look at and make sure we're just looking at the important things. And then finally, because we're moving so quickly and things might perhaps get through sometimes, we need to be able to quickly detect and respond if something does go wrong. And this is a key point for me because this is actually taking something that some people might perceive as, or some security professionals might perceive as this weakness in this sort of speed of development, the fact that you don't have all this time to do all the security, and turns it into a strength. So just as we can deploy something very quickly, we can deploy security patches very quickly. And so just as an example, when I was at my previous role, we would sometimes have a critical vulnerability on our website. And I would be lucky if we could get that patched within a week. We have had times at New Relic where we have found something and we've detected it, fixed it, and deployed a fix within half an hour. And so we're really taking what could be a weakness and turning it into a strength. So let's go back to our model then and see, okay, how are we actually going to modify this model to work? So the first thing we're going to do, and this should be pretty obvious if you've been listening to me, is we're going to remove those stop signs. And we're just going to say, we can't have the checkpoints. We can't have security signing off every single one of these phases if we're going to move this quickly. The second thing we're going to do is recognize the fact we don't have these nice clean silos anymore. So we're going to get rid of those and make this look a little bit more like it really looks when we're all doing our real development. And so now let's take a look at these individual items and say, how do we change each one of these? And I'm going to start with these first two, which is really, defining the requirements and doing that architectural review. Well, it is critical that you get security involved early in the process. In fact, that's the best time to always get security involved, because it's always way easier to fix things if you detect them early than it is if you detect them when you're about to deploy. So we do want to make sure security gets involved, but we want it to be lightweight and easy. So we've actually taken these two things and replaced it with a very simple process. This is probably one of the most formal processes we have, but it's still very lightweight. It's also actually a required process. Every new feature, every new application has to go through a required security evaluation early on in the development. And what we've done is we basically said, let's make this as easy as possible. What I want you to do as a developer is set up a short meeting, less than 25 minutes, with somebody on the security team, and just come prepared to talk about three things. First of all, give me a technical overview. Tell me what this does, how it works. We're all technical. We can understand this. The second thing is tell me the business context. What problem are you solving? When are you planning on releasing this? Who are the customers? And the reason we want to know that is we want to make sure that we're trading off security and business opportunity, and we understand that balance. And then finally, we might be the security experts, but you're the expert in your application. You've been working on this thing for a while. You tell me what you're worried about, and we'll use that as a starting point for our discussions. And so then we always have two outcomes of these conversations. The first outcome, and happens pretty often, is we say, you know what, based on this 25 minutes, this is really low risk. There's not a lot to worry about here. Maybe here's 2 or 3 things you need to think about, and when you get here, test for this. But apart from that, you're good to go. If nothing changes, you don't need to come back to us anymore. You're good. In some cases, though, we look at this and say, you know what, there's a lot more risk here. We need to actually sit down and do some whiteboarding, do a deep dive, and do one of those threat models I talked about earlier. In either case, although this is a lightweight process, it is important, it is a real process. We make sure that developers document any outcomes from these meetings and that we actually follow up and deliver on these before we release. So I've talked a few times about threat modeling, so let me talk a little bit more about what we're doing with threat modeling. So basically, threat modeling, as I said, it's a way of identifying what are the real threats against this. And traditionally, this can be a pretty heavyweight process also. I've been involved in some threat models where I had a security architect, someone very senior, spending days and days doing threat modeling. We like to do very lightweight and targeted threat models. So by lightweight, this is generally something that the security team can work with the developers to do in just a couple of days. And so what is a threat model? At the very highest level, it's a way of identifying what are the assets, what is it you're trying to protect, and what are the threats against them. And the reason I like threat models so much is it allows you to focus your potentially limited security resources where you actually have real security threats. And so I contrast this to the what I call the peanut butter model of security, where you take your security resources and spread it thinly and evenly across everything, whether it's a real threat or not. In this case, what we want to do is just focus our resources where there really is a threat. And so how do we do threat modeling at New Relic? Like I say, we try and make this very lightweight, a couple hours. And it basically falls to 5 steps. The first one is you draw out your application. You decompose. What is the data? What are the boxes? How are they talking to each other? And then you go through and say, what is it I actually want to protect? Because that's what really matters. So what is valuable here that someone might want to get at? From there, you're going to list your threats. What are all the different threats against these assets? What might people do? What might go wrong? And then it gets to the really important part, which is you go through and you rate and you rank the threats. And so we use a very simple process for this. Basically, we say for each one of these threats, what's the likelihood that it's going to occur? And then we just say high, medium, low. And then we say, okay, how bad would it be? What's the impact if it actually did happen? High, medium, low. You take those two together, and that's your ranking. And so once you've identified all these and rated them, then you can actually decide, do I want to address them? And if so, this is how I'm going to address it. You document what we're going to do to fix this. Or in some cases, you say, you know what? This has a really low score, very low risk. We're going to accept that. So that's basically threat modeling in a nutshell. I'm a huge fan of threat modeling. It's probably one of the best tools we have in the security world. If anybody wants to learn more about it, please find me after the session. I'm always happy to talk about threat modeling. So let's move on then. So we talked a little bit about secure coding practices. So this is making sure your developers are actually not introducing bugs into the code. So this becomes even more important in this world because you don't always have security eyes on everything. So you want to make sure your developers have the right training. But at the same time, you want to make it easy for them. And the way you make it easy is you create libraries that they can use or services and take a lot of the security thing and put it in one place that everybody can reuse. Basically the whole concept of reuse here. And so just give you a few examples. One of the things we built recently is a authentication service. So we basically took all the authentication that was happening various places in our code and put it in one module so that everybody could basically use that module. We can focus our resources, our limited security resources, just on analyzing this one module instead of having to look at 10 different places and hoping that developers didn't get it wrong in these 10 different places. Another good example here is encryption libraries. Encryption is something that's really, really easy to get wrong if you build your own. And so why not just have a security team or somebody build a single encryption library, everybody uses it, you make sure it's secure, and you don't have to worry about people making mistakes and security not seeing those mistakes. So that's the idea here. So then let's move on to the static analysis I talked about before. This is once again where you take your code, run it through a tool, it actually looks at your source code and shows you vulnerabilities. I've been using this for years. It's very painful in the traditional model. So unless you spend months tuning this thing, I literally mean months to tune this right, if you throw this at a big code base, you're going to end up getting a list of thousands of vulnerabilities, most of which actually tend to be false positives. And so if you try and give that to a developer and say, here, use this every time you make a change, you're not only going to scare them off of static analysis, you're going to scare them off of security. And so what we've tried to do is turn this around and make a very lightweight process. And this is actually an area where we're still trying to basically set this up. So not everything here are things that we've actually done so far. Some of this stuff is aspirational, we're still working on. And this is one of those areas where we're actually in the process of building this. And the idea here is that as soon as a developer commits code, we immediately check it out, scan it right there. Commits tend to be pretty small, and so you're not going to see a lot of results at that point. It's going to be manageable. And the way we're building this right now is using a couple of tools some of you might be familiar with. The first one is Brakeman, which is a very good open source Ruby on Rails vulnerability scanner, or source code scanner. And it works as well, if not better, than some of the commercial tools that we've looked at so far. And then we combine that with Jenkins. And like I say, as soon as the code checks in, we do the scan, we mail the results to the developers immediately. White box testing, once again, having developers be able to test things as they go. This is great. Let's make it easy. Let's give the developers very targeted tools so that they can test, vulnerabilities that we know happen over and over again. We don't want to give them the sort of tools that the security professionals use that are just going to be very confusing, but let's make sure they have very targeted tools. Dynamic analysis, if you recall, this was when we actually walked through your site, spider the site, looking for vulnerabilities just as a real user would. This is actually very similar to what we're doing in production already with vulnerability scanning. So one of the things we did at New Relic is we said, you know what, why not just make these one and the same? And so what we're doing now is continuous scanning, basically 24/7 in all of our environments, in test, staging, and production. And so this way, although we've got that vulnerability scanning in production, we generally aren't going to catch the things there. We're going to catch them in staging and test before they ever get released. And so this has been actually something that's worked very well for us. I already talked about testing, so we don't need to talk about that again. Penetration testing, once again, this is getting your white hat hacker to try and break this thing manually. Traditionally, these can take a week, 2 weeks to do right. So we're not going to be able to do that before we'd have every release. Instead, we're going to focus on continuing to do that in the production environment on a regular basis. So I talked before also about the security assessment. So at the end of the cycle, we get security come in and maybe do some manual code reviews, look at how you've built this whole thing, see if you've missed anything. This can be very heavyweight. We can't hit everything when we're releasing multiple times a day. So we've actually implemented something here that I'm really proud of. I think it's working really well, which we call sort of our automated commit triage. And the idea here is we have a script that runs nightly and looks at all the commits that happened that day. And it produces an email report, and it sends it to the security team. And so every morning, we come in and we see this report, and it's ranked all the commits for that previous day as either high risk, medium risk, or low risk. And what we're doing, it's pretty basic. We're basically looking for methods that we know have got us in trouble over and over again. We're looking for sensitive modules. So for example, if somebody's made some commits to the authentication module, that's probably a higher risk. We look for security keywords. So if your commit comment or your code has the word password or encryption or something like that in it, that's going to raise up its ranking. And so what we do is we come in the morning and we say, hey, for all these high risk, we actually have time to dig into these 3 things because there's only 3 things here. And we go and look at the code and see what happens and get real security eyes on it. For the medium, we'll just sort of scan it, anything here pop up. And the lows, we can generally just scan very quickly. And so this has been working great for us. And this is, in my mind, an excellent example of triage. The security sign-off, that's just yet another sign-off. We said already we're not going to have these sign-offs, but instead we are really going to rely here on our just quick detection and recovery. We might not get that sign-off on everything, but we know that if something gets live, we can quickly fix it and recover. Finally, move down to the bottom here, separation of duties. So this is an interesting one. This is a very common thing in security. You always talk about separation of duties in the security community. And this is basically the idea that your developers should not be releasing to production. Well, in DevOps, a lot of times we have our developers releasing to production. So how do we deal with that? Well, we deal with that through accountability. So we're saying, yes, you can release, but we want to make sure we know who is doing what when, and that we can rewind and figure out exactly what happened if something goes wrong. If we move to the management release and sign-off, so this is your manager, some sort of manager has to actually say yes for every single code. That's obviously not scalable to 20 releases a day. So what have we done? So we've actually replaced this at New Relic with a process we call our sidekick process. And so I'm not actually talking about this kind of sidekick, but actually this kind of sidekick. And the idea here is that for every release we push live, we have to get a second set of eyes on that before it can go. And we actually document who it is who reviewed that. And it's going to be either another developer or a QA engineer, but it's got to be somebody before it goes live. And then finally, limits on production access, always a good thing in security, but we have to make sure people can still do their jobs. So what we do here is we try and identify what is it they are trying to do. Why do people need this access production? And let's replace that actual access with tools that let them do their job. So that basically, if we do a little cleanup here, is the model we're using at New Relic. And in my opinion, this is working great for us, but I also think it's going to evolve. We want to be agile here just as we're agile in the rest of our business. And so some of these things we might say, there could be a better way we do this. Maybe we're going to change this. And that's fine. We just have to remember we're going to stick to the principles we talked about earlier. As long as we stick to these principles of automation, triage, and that quick detection response, and those really are probably the most important things that we found. As long as we stick to these, we're going to be able to evolve this to work in our environment. Now, I want to finish on one other note. So one of the concerns I had when I started, thinking along these directions and started evolving our security model at New Relic is, and I've heard this concern for other people too, is what about auditors? So some of you might work in regulated industries, healthcare, or you're subject to PCI, and you've got auditors come in. And if any of you had auditors come in, they come in and they want to look at your development process and how do you deploy, how do you release. And so I talked earlier about the security folks being sort of behind the curve here. If there's a group that's more behind the curve, it's the auditors. These guys know Waterfall. They're used to Waterfall. They really don't know much else. And so they're going to come in, and they're going to say, OK, where are you doing A, B, and C? And the answer for us is, we're not actually doing A, B, and C because we're doing all these different things. And so the way we approach that is with something that auditors know very well. And if any of you have worked with auditors before, you've heard the term compensating controls. Basically, the idea here is they're looking for A. We're not doing A. We're doing this over here. And what we're doing here compensates for our lack of this thing over here. And so it's basically giving us the equivalent results, just in a different way. And it really also comes down to me, and this was the biggest one, it comes down to being able to tell a story. Tell the story I just told. This is the way we are changing our models. This is what we used to do, but this is the way we have to do it in the new world because this old way just doesn't work anymore. And so how does this work? I can't speak for everybody. I can't speak for your auditors, but we've put ourselves through 2 SOC 2 audits now. And in both cases, we started exactly as I described. They came in and said, show me A, B, C, and I could not show it to them. So we told the story, and we said, this is what we're doing instead. And ultimately, at the end of the day, we've passed those audits. They've accepted those results. And I think they've got to, because this is the way we're moving as an industry. And I think we'll start to see them adopting and understanding this methodology. So with that, I want to thank you all. As you can probably tell, I'm pretty passionate about security and particularly about the evolving way, or the way we're evolving security. So if any of you want to talk to me after this, I'll be here for a little while. I'll be out in the hall, and feel free to email me at either of these addresses. So thank you very much.